Welcome learners. Welcome to this session on Relational Database Management System. Today in this module, we will learn about topics such as keys, relationships, degree of a relation, cardinality of a relation, and dependency or participation of a relation in an ER diagram. This is in continuation with our previous module on ER diagrams. Let us first discuss what are keys. A key or a key attribute are those attributes which can be uniquely used to identify records within a database. The key attributes is represented using oval and the attribute name is underlined with a line, right. So, for example, in a student table, the student ID is used to differentiate between records of the same type or having the same values. So, we consider this student ID as a primary key or a key attribute, and we represent it by highlighting it with an underline. Apart from key, we have different types of keys. First is a super key. A super key is a set of attributes, or that means it can be a single attribute or more than one attributes, which collectively are used to identify entity in a relationship or an entity set. Candidate key, it is a minimal super key which is called candidate key, and an entity set may have more than one candidate keys. These are the probable keys that you can pick up to set it as a key attribute for differentiating among records. Then out of these candidate keys, one key is chosen for this purpose of differentiating, and that key is known as a primary key. So, we can define that a primary key is one of the candidate keys chosen by the database designer to uniquely identify the entity sets. The next is relationship. But in a database, we have more than one entities together, and we should have a relationship or association between these entities. So, this association among entities is called a relationship. For example, an employee works at a department, or a student enrolls in a course. Here works at, or we can say enrolls in, these are called relationship because they involve more than one entities together. A relationship type represents the association between entities, and we have different types of relationships. In an ER diagram, this relationship type is represented using a diamond box. So, we can say that we have two entities here. First is a student, second one is the course. Here this student is an entity, this course is an entity, and they both are linked together by association or a relation which is called enrolled in. So, we can say that a student enrolls in a course. Next is relationship set. A set of relationships of similar type is called relationship set. Set means a group. So, a group of relationships is called a relationship set. Here if you see in this description or the diagram, we have here S1, S2, S3 represents the records of first entity. Then we have C1, C2, C3 that represents another entity, say course, and this S1, S2, S3 is for the student, and they both are linked together by means of another relationship. And here S1 is enrolled in course S2, student 1 is enrolled. So, enrollment E1, it is associated with course C2, S2 is associated or enrolled with C1, and S3 is enrolled in C3. Like entities, a relationship too can have attributes. So, we can have extra attributes also, like since when it is enrolled or other information related to this, which we cannot put either in the entity student nor in the entity course. All these attributes are called descriptive attributes. Then we have degree of relationship set. The number of different entity sets participating in a relationship is called the degree. Based upon this, we have unary relationship, we have binary relationship, we have ternary relationship, and we have n-ary relationship. Unary means single. So, if we only have one entity in a relationship, it is called unary relationship. Binary means two. If we have two entities involved in a relationship, it is called binary relationship. Ternary means three. So, if we have three entities involved in a relationship, it is called ternary. And n-ary means if we have more than three entities that are linked together in a single association, it is called n-ary relationship. For example, one person is married only to one person. Here the main entity is person and the relationship is married to, right. So, here since only one entity is involved, so this is called unary relationship. Binary relationship. Here a student is enrolled in a course. So, we have two entities. The first one represents student, second one is course. They both are linked together by an association which is called enrolled in. So, we have two entities involved, that is why it is called a binary relationship. The third one is ternary. For example, a doctor has prescribed a medicine to a patient. So, here we have to identify the entities that are involved in this. First we have a doctor, then we have a patient, and the third one is the medicine. And how all these are linked together? They all are a part of a prescription in which a doctor prescribes a certain medicine to a patient. So, we have three entities involved, that is why it is called a ternary relationship. In all the complex databases, we have more than one entities involved generally. So, they are n-array relationship, where n represents the number of sets that are participating in that relationship. Then we have a term called cardinality. Cardinality is the number of times an entity of one entity set participates in a relationship set. It is also referred to the relationship between two tables. So, if we are connecting two tables together, how many elements of one table or records of one table are matching or associated with the records of the other table, this number is called cardinality, or we can also say that they are called mapping cardinalities. So, based upon this, we have four types of cardinalities: one to one, one to many, many to one, and many to many. Let us first discuss one to one cardinality. In this figure, we have a relationship between an employee and a department, and the association is works for. That means an employee works for a department. So, we have two entities here. This employee is related to department by means of an association or a relation called works for. So, the relationship of say D1 is a department 1, this department is associated with two entities from employee table or employee entity. Here E1 and E2 are associated with D1. So, this is called one to many. That means one element or entity value of one table or an entity is related to more than one. So, this is one to many. One department has many employees. Similarly, in the same diagram, if you see the association between E3 and D2, E3 is directly connected to D2 and there is no other entity which is connected to D2. That means this is called one to one association or one to one cardinality. One entity of one set is connected to one entity of the other. Next, one to one relationship, again we have two entities, one male, one female. The relationship between them is married to. So, one male is married to one female. This is called one to one association. Next is many to many. Generally, in our database, we can control one to one, one to many, many to one, but to control many to many relationship is a very complex task, and we generally do not want our databases to be of many to many type, because in that case it is very difficult to identify what all entities of one are mapped to what all entities of the other. There are ways to reduce this many to many association using a concept called normalization that we will study in the coming modules. So, here we have an example in which we have two entities, first is student, second is course. Here to represent this kind of cardinality, we represents MN. It shows that many students can enroll in many courses. Right. So, here also, here at one side we have many entities, on the other side we also have many entities, right. So, such association is called many to many relationship. Then dependency or participation. It can be defined as an association among different entities. A participation constraint is applied on entity participating in a relationship set. Based upon this, we can have two types of participation. First is called a total participation, in which all the entities are mapped with the other entity, and partial participation, in which some entities are mapped with the other entities. First we look at total participation. In total participation, each entity in an entity set must participate in a relationship. For example, we have students and we have course. If each student is enrolled in some other course or some course, the participation is called total. For total participation, we represent with a double line. Like in this diagram, we have a double line showing that all the students are enrolled in some other course, not in one course, but maybe other. There is no student left. If you see a diagram here on the right side, we have S1 that is mapped with C3, S2 it is registered for C1, S3 registered for C3, S4 registered for C4. So, none of the elements in this student relation is empty. Okay. This shows that this is a total participation. The next type of participation is called partial participation, in which not all the entities are mapped. Okay. So, here you can see S1 is registered in C3, S2 in C1, S3 in C3, S4 in C4. All the values of S are somehow mapped, but all the values of this course is not mapped. We have this C4 left behind. Such is called partial participation, right. Here there are three ways of representing the things using ER diagram approach. First is called Schenck notation, next is Crowfoot notation, and UML class diagram notation. Schenck notation is a very commonly used notation that we are following till now, in which entities are represented by rectangles and relationships by diamond shapes. Attributes are represented using the ellipses or oval boxes. In Crowfoot, we have representation like this. Entities are represented, but we have to highlight the entity, that is, suppose here we have painter and another entity is painting. So, we have to write their names, then we have to leave a space blank here. We will link them together using a line. Here all painters make some painting. So, here we show it with 2 dashes here and 1 dash with a Crowfoot kind of notation. That is why this diagram is called a Crowfoot diagram. Generally for higher order diagrams we use Crowfoot and UML class representation, but for basic understanding we generally use ER diagrams. So, it is represented in UML class notation like this. To represent many to many relationship, for example, an employee can have many skills. In a normal ER diagram or a Schenck notation, we have an employee, we have a skill, they are linked together by a relationship called learns. Here many employees can have many skills, so it is many to many relationship. In a Crowfoot notation, both the ends should have a Crowfoot, and in UML class diagram it is represented like this. Then we have one to one association, in which one employee manages one store. So, the association is 1 to 1. Using the Crowfoot notation we have this notation, and for UML class diagram notation we use this representation. Let us see what we have seen in this module. We have started with keys, we have seen different keys. We learned about various relationships that exist. We have seen the degrees of relationship. We have seen the concept of cardinality and also the dependency or participation of an entity in a relation. I hope this session is beneficial for you. In the next session, we will be looking more into extended ER features. Till then, happy learning. Thank you.